I'm Jake, and I'm going to talk about why I made Sourdough, which is a new vector tile schema for OpenStreetMap. I'll try and talk fast so that the comedy shepherd's hook doesn't drag me off the stage. So we've already heard some about OpenStreetMap today, but if you're not familiar, OpenStreetMap is this free map of the world that anyone can edit. If you go to OpenStreetMap.org, you'll see a map that looks like this. But unlike most maps, if you, this is what it looks like in the building we're in right now. Unlike most maps, you can click the edit button at the top of the screen, and anyone can create an account and edit the map. So you can add things that are missing, you can correct things that are wrong, you can change the shapes of things like the buildings and roads on that you see on the screen, line them up with the satellite imagery if they're not appropriately aligned. You can also change all the metadata, so you can change the name of this building, you can change the speed limit on the road outside. You can edit anything that needs attention, and when you click save, your edits are published for everyone in the world. It's kind of crazy. Two important things to understand about OpenStreetMap. Number one is that it's not really just a map. Like, you can see OpenStreetMap on OpenStreetMap.org, but the goal of the project is to create this free, collaboratively maintained geospatial data set of everything that physically exists. The data itself, the database dump of OpenStreetMap, you can go download, and you can use for anything you want. You can make your own maps, you can put them in commercial software, you can do scientific analysis, you can make art, you can do all sorts of things. And the second thing to understand about OpenStreetMap is that it's not just buildings and roads and kind of the usual suspects that you see on, say, Google Maps. It tries to catalog everything that physically exists in the world. So things that people are mapping in OpenStreetMap right now are the locations of little free libraries, or polling stations and ballot drop boxes, or flock surveillance cameras. So just because you don't expect to see these things on most maps doesn't mean that OpenStreetMap isn't a platform that tries to catalog the locations of those kinds of things. And because of those two facts, it's possible to make some really interesting maps with OpenStreetMap data that depict aspects of the world that you're not used to seeing every day. And one example of that is OpenInfraMap. So this is a website that displays OpenStreetMap data, but instead of focusing on the buildings and the roads, like most maps would, it focuses on infrastructure. So this is an image of OpenInfraMap's power infrastructure map of Washington. These are power lines, and they're color-coded by their voltage, and then the icons are indicating different types of power stations. And this is OpenStreetMap data. It's just being rendered through a lens that highlights a specific type of information. Another example of that is Open Railway Map. Similar idea. This is OpenStreetMap data, but being rendered in a way that highlights the rail corridors and the railway stations in the Northeast. OpenStreetMap-based maps can be useful. They can also just be fun. One of my favorite examples of that is Mascot Map, which is written by Matt, who's here today. Mascot Map shows schools in OpenStreetMap, and the icons indicate what the mascot of that school's sports team is. And I love these kinds of maps for two reasons. One is they're fun. They show you something interesting about the world that you might not have seen before. And two, they create this positive feedback loop within the OpenStreetMap community. OpenStreetMap is primarily maintained by volunteers, and there's no better way to motivate those volunteers to add missing data to the map than to show them some cool use case of that data. And I think nothing could illustrate that better than this graph, which is the prevalence of the tag mascot, which is how you indicate the mascot of a school. This tag has been documented for like 15 years, but nobody was using it until Matt made Mascot Map, and then overnight people were excited about adding that information. And now this information is freely available in OpenStreetMap for anyone to use. Okay, so what's Sourdough, and why did I make it? Sourdough is a schema for representing OSM data in vector tile format. We'll talk a little bit more about vector tiles, but they are one of the main technologies that powers a lot of the interactive zoomable maps that you see on the web and in mobile apps. It's a schema in the sense that it's a description of how to transform OpenStreetMap data into vector tiles. It's also a reference implementation, a piece of software that does that transformation using the Planetiler framework. But really at a high level, Sourdough is a tool for cartographers to create inventive new types of maps, like the ones I've been showing. So vector tiles, really briefly, are a solution to the problem that the world is really big and OpenStreetMap has lots of data about it, so OpenStreetMap's database is really big. It's like 85 gigabytes right now. It's too big to fit on your phone. It would be unreasonable to expect someone who visits your website to download that whole data set before they can see your map. So the solution is to take the data, cut it up into a bunch of little square pieces called tiles, and in the specific case of vector tiles, the tiles contain geodata. They contain like points, lines, and polygons with attached metadata. And then they get rendered into a visual depiction, like a map, by code that's running in the browser or on the mobile app. So there's kind of two steps to this process of making these tiled web maps. The first is to take the OpenStreetMap dataset and convert it into vector tiles. And that's the part that is the responsibility of the tile schema and the code that implements that schema. And when you do that, you're building tiles for a bunch of different zoom levels. You have to build high zoom tiles that show you all the details of the world when you zoom in really far. You also have to build low zoom tiles that show you kind of a summary information. Because if you zoom out and look at all of North America, it doesn't make sense to like include every fire hydrant in that tile because it would be way too much data and it's not going to show up on the map anyway. So you're building these tiles for kind of at different levels of summarization. Once you have tiles, the last step is to apply a style sheet. And that's kind of like a CSS style sheet if you're a web developer. It dictates the appearance of the data on the map. So this is where a lot of like what we think of as the cartography happens, where you can change the colors and the line weights and fonts that are used for labels. But something that's important to note is that cartography is actually happening at both of these steps, because when you're building the tiles, you have to make decisions about what's relevant for your map's use case, because you can't include everything. You have to summarize. You especially have to summarize at low zooms, but even at high zooms, you're probably making editorial decisions about what are you going to depict on your map and what data needs to be present in your tiles. There are a couple of existing schemas for vector tiles that are open source and publicly available and that you can use to make vector tile maps. Open map tiles and shortbread. Both of these projects are great. They're really mature. They're very well documented. They've been around for a long time. They're really widely used. There's lots of open source example map style sheets that are compatible with both of these tile schemas. And they're, you can use those to make your own maps. You can use them as a starting point and customize them. But something interesting that I started to notice when I looked at these schemas is that they both make a lot of the same trade-offs when thinking about how to optimize vector tiles for different use cases. They both optimize for small tile sizes, and they do that by including only the data that's necessary for general purpose maps. So they include data from OpenStreetMap about roads, buildings, POIs, some basic land cover information. But they don't include a lot of other data that's not relevant for general purpose types of maps. And along the way, they also kind of reorganize and simplify the OSM data model to try and make to kind of like file off the rough edges and the idiosyncrasies of OpenStreetMap tags and make it easier to use and more approachable for the cartographer that's writing the style sheet for those vector tiles. These are all, I want to emphasize, these are all very reasonable trade-offs. And it's not, designing a vector tile schema is a game of trade-offs, and these are reasonable decisions to make. But a consequence of these decisions is that you can't use open map tiles or shortbread to build the kinds of maps that I was showing earlier, like open infra map or mascot map, because the data is not in those tiles, and you can't render what's not there. So Sourdough was kind of an experiment in what if you just took the opposite trade-offs for all of those design decisions. Sourdough, instead of optimizing for small tile size, Sourdough tries to put as much data in the tiles as possible. And by as much data as possible, I mean right up to the breaking point where you can no longer get reasonable performance from your web map. Also, instead of trying to simplify and abstract the OpenStreetMap data model, what if you just directly exposed as much of it as directly as possible for the cartographer to use? So existing schemas are optimizing for production maps that are in the style of Google Maps or Apple Maps, where they're road atlas data, or where they're depicting a map that's a kind of a standard road atlas. And they're also trying to reorganize and simplify OpenStreetMap data for ease of use. Sourdough is kind of aimed at prototyping and experimentation. So the tiles are large, but it affords you a lot of flexibility in what you might choose to display from them. And it also presents OpenStreetMap data in a very unfiltered, kind of raw format where you, the cartographer, have to deal with a lot of the idiosyncrasies of the data model, but you also have maximum flexibility for how to interpret the data. So as I mentioned, Sourdough tiles are packed full of data. At zoom level 15, which shows kind of the scale of like a few city blocks, it includes nearly everything that's in OpenStreetMap. Which is more than you would ever want to responsibly display at once. But it gives you choices about what to highlight. And also, Sourdough takes a very conservative, or a very generous, I should say, approach to pruning out features when you zoom out and you have to summarize. most, OpenMap tiles and shortbread both are kind of approaching this problem from what's the bare minimum we need to include at zoom level 6 to satisfy a particular cartographic use case. And Sourdough is looking at how much stuff can we fit in the tile at zoom level 6 without exceeding a kind of tile size budget. I tried to aim to have about 99% of the tiles be under 100 kilobytes. I talked about kind of Sourdough doesn't really transform the OpenStreetMap schema, it just presents it directly. So OpenStreetMap has this concept of top-level tags, which are like categories that most stuff in OpenStreetMap will fall into one of these categories. And Sourdough just exposes each of those categories as a tile layer, which is like a collection, a named collection of features in the tile. And within each of those tile layers, all of the features will have a set of attributes that are just taken, they're one-to-one with OpenStreetMap tags that would be relevant for that kind of feature. So in the buildings layer, you have all these attributes, and each one of these is just the name of an OpenStreetMap tag that's probably relevant to buildings. And there's a lot of stuff in here. There's a lot of attributes on the features, in addition to having a lot of features in the tiles. So you have, you can visualize buildings based on a lot of their different properties if you wanted to make those cartographic choices in your map. And this also is useful for documentation purposes, because Sourdough doesn't really have to invent and then describe its own model of how to describe and model things in the physical world. We can just forward the decisions that are being made by the OpenStreetMap community and use their documentation. So if you're wondering what roof material, like what are the possible values for roof material in Sourdough tiles, you can just go to the OpenStreetMap wiki and look at the tag roof material. All the documentation's already there. Sourdough's goals are to be easy to understand, and by that I mean to not create additional abstractions where they're not needed, to just present the OpenStreetMap data directly. Also to support cartographic experimentation. So Sourdough is not necessarily optimized for production maps, but it's a test bed that you can use to explore cartographic possibilities with OpenStreetMap. To showcase OSM's taxonomy and help improve it, and by that I mean OpenStreetMap's data model is constantly evolving, and it has rough edges and idiosyncrasies and things that the community is often talking about. How do we improve this? Is there a better way to model the world than what we're doing today? And I think by presenting that to cartographers and letting them experience it directly, it creates a useful feedback mechanism for the OpenStreetMap community, for us to kind of work on improving the data schema and making it more understandable. And finally, Sourdough is kind of a hackable starting point. If you build a prototype map with Sourdough and then you kind of decide you've outgrown the schema, you need to eject from it and optimize the tiles more or add data that's maybe missing from Sourdough. The code for Sourdough is very easy to modify. It's very simple. It's very well commented. So you can fork that code and make your own tiles very easily. Sourdough's schema and codebase are CC0 licensed. They're in the public domain. So you can do whatever you want with them, and you don't need to ask permission. Things that are on the roadmap. So Sourdough is kind of in an experimental early phase right now. It's something that I hacked together a few months ago and just released. And I'm hoping to refine the schema, solve some kind of edge case problems about how to model specific types of data, especially around relations in OpenStreetMap, and then release a 1.0 version maybe early next year. That will be, from then on, the schema will be backwards compatible. So in that time, if you're interested in providing feedback, I'd be, if you want to try out Sourdough and use it to make maps and tell me what you think of it, that would be very helpful. I'm also working on some example style sheets that will be available soon that demonstrate how to use Sourdough to make different types of maps. And I'm working on some tile size benchmarks to understand exactly how much bigger are Sourdough tiles than existing schemas. There's some open issues on GitHub right now that I've put up talking about different problems that need solving in the Sourdough schema. So if you have thoughts on any of these, certainly welcome. And this is the QR code for the documentation website for Sourdough. There's a viewer there, which I think I actually haven't maybe enough time to show you. But there's a data viewer that lets you explore the Sourdough tile schema. There's also documentation about the schema and what's included in it. And so I think I have a minute. I will show you. This is a comparison of OpenMap tiles on the left, shortbread in the center, and Sourdough on the right. I should have labeled these. And the illustration that I want to show here is that there's a lot of data in all three of these schemas, but there is more data available in the Sourdough tiles, and as a result, they're bigger than these other tiles. So at low zooms, shortbread only has country boundaries and some city and state labels. OpenMapTiles has some roads and state boundaries and certain land cover classes. But Sourdough has a lot of data, even at this zoom level, about like individual park units and protected areas. It has more roads. As you zoom in further, there's more data available in Sourdough at the expense of tile sizes. So at this zoom level, we have rivers, railways, power lines, lots of features that are not available at any zoom in existing schemas because they're optimizing for a narrower use case. And if I zoom in even further, Sourdough has more POIs at low zooms. Zoom in right on where we are. If I can zoom in on the university. At really high zoom, Sourdough has things like individual benches, bike parking, street lamps, individual trees, stuff that's in OpenStreetMap, but increases the tile sizes a lot, but why not put it in there? Someone might have a cartographic use case for it. So I think that's all the time I have. I don't know if I have time for maybe one question. Yeah.
Just want to ask, so how does that schema look? Is it like an XML file? And the second one is, what tool do you use to produce your tiles?
Yeah. So the schema is basically a text description. So anyone, it's not structured data, but anyone could follow this set of instructions and kind of re-implement a Sourdough compatible tile set using a lot of, like there are a bunch of different tools for generating vector tiles. You could use Postgres, you could use Tippecanoe potentially. The reference implementation of Sourdough is written in Planetiler, which is a Java program that generates vector tiles from OpenStreetMap data. And it's great because it's really performant on modest hardware. Like I can tile all of Washington in about a minute on my laptop. And you can tile the whole world in a couple of hours on a server that costs a few dollars to rent. Yeah.
So you had to keep things within like the breaking point you were talking about where the map still work.
Yeah.
Are there any hard decisions about, like, did you have to cut out some data at any point? And were there any hard decisions there?
Yeah, there are, that's like several of the open issues to solve are like, at what, is it appropriate to cut out this data, and if so, when? One of the things that comes to mind is indoor features. So OpenStreetMap has maps of like the interiors of airports and malls and large buildings like that. That data is not included right now because it makes the tiles too big, not on average, but like some of the outliers. Like if you zoom in on San Francisco Airport, at zoom 15, it creates too much additional data in the tiles to include the indoor features. Zoom 15 is the maximum that Planetiler supports right now. I want to get zoom 16 support built into Planetiler, just like a int32 to int64 kind of problem, basically. Once that happens, then I want to include indoor features in Sourdough at zoom 16. Yeah.
I think let's call it there for now.
I'm happy to take more questions about this in the coffee break. Thank you so much.